Recording. Okay, I think our class today will be like 1 hour lebih-lebih sikit lah kot. Alright, so yesterday, okay, I have started recording. So yesterday we talked about specific heat, latent heat, and calorimetry. But calorimetry ni kita baru macam touch sikit je. Nanti kita akan go in deeper today. So latent heat, latent means hidden, which means that you are not seeing the temperature difference. No increase in temperature, so you can't see it. No increase in temperature. Whereas specific heat, when you supply heat, the temperature of the substance that you give the heat, you give Q to a substance, for example, a metal, you will see that the temperature increases. So specific heat, the temperature increases. And the equation for specific heat is Q equals to mc delta T. And as I mentioned to you before, delta T is T final minus T initial. Always, that is always the case. Kalau ada orang cakap delta ni initial minus final, memang salah lah. Memang in physics, it's final minus initial. So your delta T can either be positive or it can either be negative. Kalau T final is lower than what you started with, let's say you started with 20 and then you put it in the fridge, so your T final is 0. So your T final is 0 minus 20, so that's a negative delta lah kan, it's negative 20. So here you will get that your Q will be a negative sign. When it is a negative sign, it means that your substance is releasing heat energy. That is why it became cooler. Same case here for latent heat. When it is a negative, it is releasing heat. When it is a positive, it is absorbing the heat. Okay, benda ni penting sebab plus minus Q ni, we will see this in chapter 15. And I will be doing a video on that for your Instagram. Instagram dah uploaded chapter 13, I believe, by Mr. Umair. Dia akan jadi doktor soon, so Dr. Umair to be. So Dr. Umar dah upload on Instagram chapter 13. If you guys want to do some revision using his video, by all means, please do that. If you are more comfortable with my video, you can just go to my YouTube playlist and just tengok our past classes. That's fine. Either way, it's fine, as long as you understand what you're learning. Okay, so M is your mass. This guy is in kilogram, always SI unit. This T is in degrees Celsius. This C is your specific heat capacity. So it depends on your material. You will have different C's. Q is a type of energy, so that is in joules. We already know this. Saya dah ulang-ulang daripada awal semester. So energy, always joules. And I take, saya menitik beratkan. I don't know what that is in English. Usually I have the words in English but not in Malay. Tapi saya hari ni ingat Malay pula. So saya sangat menekankan on units because units can make you or break you. You can use the equation, but if your units are wrong, your answers are totally wrong. So saya tak berlembut kat situ. So you really need to know your units. So plus minus ml. M is also in kilogram. This guy is in joules. L is your latent heat. And we have discovered that we have two types of latent heat, which is LF, your latent heat of fusion. This guy goes from liquid to solid or vice versa. Liquid to solid is latent heat of fusion. So that's a L, capital L with subscript F. And then you also have latent heat of vaporization. And you know this is liquid to gas. Okay, sorry lah huru-hara kat sini. And vice versa. Okay, macam mana nak tahu vice versa tu? Kalau latent heat liquid to solid, it is going to release energy sebab dia akan jadi sejuk kan. Liquid to solid, you have to give up heat. You have to give up heat, which means that your Q will be a negative sign. If you are turning your solid to liquid, you need to absorb heat because why? When you are trying to heat up ice, you are supplying Q to the ice to become liquid. So Q is positive because the ice is absorbing Q to become water. Okay, so this is the L value. The same LF is used to change liquid to solid and solid to liquid. Okay, jangan confuse kat sini LF yang sama, I'm going to repeat myself, LF, the same LF is used to change liquid to solid and solid to liquid. What differentiates them is the sign of the Q. Okay, positive Q, absorb, negative Q, release. Okay, sama juga for LV. If you are changing liquid to gas, you need to absorb energy. That's a positive Q. You use LV. If you are changing gas to liquid, you are releasing energy. You still use LV. It's the same LV. It's the same constant. Okay, sama. LV dengan LF tu sama. But the Q can either be positive or negative. All right. And then calorimetry. I told you we have an isolated system. Nanti kita akan tengok lagi. We have an isolated system. Isolated system means that it is protected from the outside world. So anything that happens inside the calorimetry is purely because of what is inside, and the outside environment will not affect the inside. So dia tak akan terganggu lah kalau ada orang jerit-jerit pun dia tak dengar. Contohlah macam tu lah. So I'm in my house, there's a monkey outside who's like chattering to his friend. I can't hear him because I am sheltered in my house. So sama juga, this metal is interacting with the water inside this calorimetry. Whatever goes out here, the sun dia nak sun ke, dia nak hujan ke, dia tak kisah. Isyap nak goreng telur lagi ke hari ni? Terlupa mute lagi. Main jangan ambil hati. Okay, so let's talk about the calorimetry. Oh, forgot. Ada lagi equation tak yang saya terlepas? Ada, okay. JKGL. Okay, graph ni. We also talked about this graph yesterday, and this guy means there's no change in temperature because dia stagnant kat sini. Even though we supply more Q, the temperature remains the same. This is what the straight line means. Temperature remains the same. Okay, and this guy means the temperature is increasing, temperature is increasing, temperature is increasing. This is where the latent heat happens or the phase change happens. Okay, so let's label that. Whoopsie. Phase change. Okay, you guys know this. So this is MC delta T. This is ML, MC delta T, ML, MC delta T. Okay, so phase change ML, increasing temperature MC delta T. What type of L should you use? From solid to liquid, it's fusion, liquid to gas, it's vaporization, vice versa. Okay, senang je. Senang je. Phase change is over. Okay, dah tahu. This one. Okay, calorimetry. We've talked about this slide. Let me recap on this part. Q cold equals to Q hot, or Q hot equals to Q cold, which means that heat gain is equal to heat loss. The heat loss by the metal is the heat gain by the water. Because they are in isolated system, semua heat tu pergi dekat water instead of going to the environment. So we can say that when we minus Q cold with Q hot, it will give us a 0. And this is what this equation means. So Q cold minus Q hot will give us a 0. So there is no increase in heat energy, or there is no decrease in heat energy. Everything is conserved. Okay, everything is conserved. In the above equation, the change in temperature is delta T, T final minus T initial. Okay, good. Okay, let's do this example first. Ada example tak untuk ni? We have done this one. Have we done this one? Forgot. Oh no, kita buat yang lain. Kita cari calorimetry punya soalan jap. Okay, this one. This is the question on calorimetry. Okay, so 100 gram. Okay, this point. Soalan ni pun calorimetry juga. Okay, how do I know? Okay, let me tell you how to identify. Hello. Okay. How much energy is required to change 400 grams of ice cube from ice at 10 degrees to steam? So this guy, it did not say there is no transfer. Dia tak cakap there's no transfer to the environment, there's no heat transfer, or there's no energy transfer to the environment. It's not in an isolated system, so I am going to assume this is not isolated. Assumption, not isolated. Okay, tapi tengok-tengok Tanta solution dia pakai calorimetry kan. Selalu macam tu. But based on this question, apa yang kita faham, how much energy is required to change a 400 gram ice cube from ice at -10 to steam at 110. So it doesn't say it's an isolated system. So it just wants to know how much is the energy to change the ice cube to become steam. So let's do that first. Sikit kita nak buat lah. Kita buat dulu eh. Okay, let's do this together. Let me duplicate this slide. Okay. You guys have to help me because saya pun tak buat lagi sebenarnya. Okay, let's do this together. Hello. Okay. So how much energy is required? Okay, so we start with ice. So ice is in solid. It is at -10 degrees Celsius. And then what's the next step? Let's do this together. What's the next step? What do I have to, I supply heat. What happens to the ice?
It change into water at 0 temperature.
It change into water at 0 temperature. Okay, correct. But before it becomes water, what does it have to go through?
Latent heat.
Latent heat of fusion.
Latent heat of fusion. Okay, I'm just going to write that first. Latent heat of fusion. Okay, so latent heat of fusion. There's no change in temperature, right? No change in temperature. The equation is ml. So how does my ice at -10 degrees Celsius becomes water at -10 degrees Celsius?
We need to change the temperature of ice to 0
Yes,
Celsius first.
Betul. Thank you, Afika. We need to change the ice from -10 to become 0. So how do we do that? So I supply Q. It does not change phase yet. It increases in temperature first. So ice increase in temperature to 0 degrees. So this equation is Q equals to, kita baru buat semalam. Q equals to MC delta T. Okay, so betul Afika. First, we need to erase the temperature of the solid to become 0 degrees. Now comes the latent heat. Okay, let's use red again. Now comes the latent heat. So Q equals to ml. So now my ice at 0 degrees Celsius can become water at 0 degrees Celsius. So this equation is Q equals to ml. So let's label this Q1. This guy as Q2. Okay, is everyone following me? Okay ke? Faham why we have the ice at 0? All right. Good. So moving on, what's the next step? What's the next step if I want to go to steam?
We do the latent heat.
We increase
change into
the
water.
temperature of water.
We increase the temperature of water. Seorang cakap increase the temperature. Seorang cakap latent heat. What's the right answer, guys?
Increase the temperature.
Increase temperature.
Dulu, yes. To what degree Celsius?
100 degrees.
100 degree.
Yes. So this guy equation dia Q equals to MC delta T. Okay, you guys are getting it. That's good. Okay, next. Water is at 100 degrees Celsius. How do I change it to steam?
Latent heat of
Latent
vaporization.
heat. Yeah.
heat.
So this becomes gas or steam. Let's write steam. So steam. So to convert water to steam, this is latent heat. Okay, siapa yang suka sangat latent heat tu? Yay, it's latent heat now. So ml, steam. So steam is still 100 degrees Celsius. Now, what do I do to make it 120?
Increase the temperature.
Increase the temperature, yes. So after increasing the temperature, is there any latent heat going to happen? Does steam become something else?
No.
Tak ada
No.
Kalau ada tu macam takut dah juga kan. Tak ada Lepas steam habis. Unless dia patah balik. Jangan pandai-pandai pula lepas steam ada benda lain. Okay. So this guy, steam.
100. 110.
Oh, 110, thank you.
Total
110, thank you. Tak perasan. This guy is 110. So this is Q5 MC delta T. Okay, so now we have 1, 2, 3, 4, 5 Qs that we need to calculate. So let's do that. Excuse me. Group. Kesiannya benda ni. Kejap saya tulis balik. Dia tercicir. So this guy, steam. 120, sorry. Suka sangat 120 ni. Celsius Q5 equals to MC delta T. Okay. So now let's write the equation. Let's use green. So Q1. So we already know the equation MC delta T. What is my M here? What is my M here?
0.4 kg.
0.4 kg.
0.4 kg. So we need to convert our mass into SI units. So 0.4 kg. What is the C that I should use here?
Sea ice.
C
Sea
ice,
ice.
correct. So C ice, 2.09 times 10 to the 3 joules per kilogram per Celsius. So kat sini dah kasih hint dah. Kena in kg, kena in Celsius. So what is my temperature difference here? What is my T new?
Zero.
Zero. So kita nak tengok kat sini je. We just want to talk about this part only. So it's 0 minus 0. 0 minus 0. Okay, so because T new minus T initial, so negatif ni ada kat sini, tapi yang T naught pun negatif juga, so it becomes positive. So when it becomes positive, my Q is positive. What is it doing? What does it mean when my Q is positive?
The temperature rise.
The temperature rise. Is it releasing or
Absorb
absorbing
energy.
heat? It is absorbing heat. Okay, good. So, yang ni tak tahulah, nanti kita kira. So Q2 ml. Mass is still the same, 0.4. And what should my L be here? What should my L be here?
LF.
LF, yes, this guy will be LF. Kita nak convert ice to water, it's fusion. So it's LF. So that is 3.33 times 10 to the 5. So that is it. Kita punya ni dah in kg, so we don't have to worry about it. All right, Q3. Oh, I don't have the space. Okay, let's do it here. Okay, Q3 tak nampak. Sekejap. Okay, different color. Q3, okay, nampak. MC delta T. So M is 0.4. We know this already. C. What is my C? Q3 is this guy over here. Water to water. What is my C?
Seawater.
Seawater. Okay, so seawater is 4.186 times 10 to the 3. What is my delta T?
100 minus 0.
100.
100 minus 0. Yes, so it's just 100 or 100 minus 0. Boleh juga. And then let's go for Q4. Q4 is ml. M we know is 0.4. Semua sama 0.4, 0.4, 0.4. So takkan tiba-tiba berubah pula kan mass dia. So mass does not change. What is the L that I should use for Q4? Q4 is over here, water to steam.
L
Is it latent
heat of
vaporization.
Latent heat of vaporization. Vapor means steam. So latent heat of vaporization. So LV. So 2.26 times 10 to the 6. Okay. And then we have our final one, Q5, which is MC delta T, and our M does not change. What is my C that I should use here?
CC.
Steam. Okay, dah senang dah kan? Dah faham dah. The thing that makes it easy, I think, is drawing this diagram first. Betul tak? Labeling Q1, Q2, Q3,
Betul.
plug in the numbers. So if you want to avoid confusion, please follow these steps. 0.4, system 2.01. 2.01 times 10 to the 3. What is our T?
110 minus 100.
110 minus 100, correct. Kita hanya tengok this period only because we are only talking about Q5. Okay, so now how do I macam check back on my work when I'm done plugging in the numbers and stuff and I use my calculator blah blah blah, dah habis lah kiranya. How do I know that this diagram is correct? Are there any tips that we can follow? How do I know this diagram is correct?
We look at Q sama ada dia positive or negative.
Boleh, we can look at either if it is going to become steam, it will always be positive Q, betul? That is one thing to observe, whether Q is absorbed or not. Kalau tiba-tiba dapat Q negative, but you are converting ice to steam, so kat situ dah red flag, betul tak? Q is absorbed or released. So kat sini boleh check, is it making sense or not? The second tip that you can use to check your work is just looking at this, you alternate between MC delta T and ML. So MC delta T, ML, MC delta T, ML, MC delta T, lepas steam habis lah, jangan pandai-pandai tambah So it is alternating. Dia bukan MC delta T, MC delta T, MC delta T. Dia bukan ML, tak. Dia berubah-ubah So MC delta T and then ML, MC delta T and then ML. So use these tips So MC delta T and ML should alternate. Should alternate. Betul lah. Should alternate. Okay. So tak ada there's no ML and then ML. There's no ice at 0 degrees Celsius convert to water, 0 degrees Celsius convert to steam, 0 degrees Celsius, because ML does not increase the temperature. So how do you become steam? Okay, so you have to have the MC delta T. Okay, so let's see if our work is correct. This is number 14.5. Okay, praying that we menafsirkan soalan tu dengan tepat. So 0.4, 2.9, 333, blah, blah, blah. 00, betul, 100. Okay, I think we got it right, except that I did not use my calculator. But you can do that if you want to double check on it. So dari segi working steps, I think we got it. Okay, first start with your diagram yang ada arrow-arrow tu. Let's call it the arrow diagram. Okay lah, kita panggil arrow diagram je lah. It's not official. It's not an official name. It's official for us, for our class. So we call it the arrow diagram je lah to make it easy. So first start with your arrow diagram, then only plug in your numbers. Label your arrow diagram with Q1, Q2, Q3, Q4, Q5, and then baru buat your equations. Okay, moving on to the next question. Duplicate slide, waiting up. Okay. Kita buat yang ni. Kita nak So this is the question that we are looking at now. Exercise 14.6. Let's do this together. Hari ni saya tak ada mood sangat nak panggil lucky winner. Mesti korang macam, yay, doktor tak panggil. Okay. Tapi buat juga sama-sama tau. Jangan tak buat. Okay. Right, so this is 23, right? Kejap. Jawapan dia 23. Okay. Let's do this one. A 0.4 kilogram iron that is initially, so we have an initial temperature 500 degrees Celsius. So let's write that down. This is what I like to do. I write down all the info. So 0.4 kilogram of iron. So it's an iron. Initially at T naught is 500 degrees Celsius, is dropped into a bucket containing 20 kilogram of water at 22 degrees Celsius. So this guy is iron and we have water and the mass is 20 kilogram. Temperature is, okay, so since we have two substance, let's label that as Ti, this guy. Okay, too confusing. That looks like T initial. Let's write TIR. TIR means T iron. Then this guy is T water. So that is 22 degrees Celsius. What is the final equilibrium temperature? What does it mean by this? What does it mean when they want you to find the final equilibrium temperature? Anyone? Any ideas? Dun, dun, dun.
You
So
make
neglect
Q equal to Q.
Q equal to 0.
Q, net Q equals to 0, betul? Bukan Q equals to 0 net Q equals to 0. Okay. Net Q equals to 0, betul? I think that was Zafira, right? Zafira yang cakap kan? Tadi lagi seorang jawab apa tadi? Saya tak perasan. Net Q equals to 0. I think it was Umar. Was it Umar?
Yes.
Umar cakap apa tadi?
The
equals to
Q
Q,
iron
kan?
equal to Q, yeah.
Q iron equals to Q
Q
water.
water.
Okay, Q iron equals to Q water. Okay, so Umar, can you tell me why you said Q iron equals to Q water?
Because the iron is being dropped into the water, so between the two objects, the heat is being transferred to each other.
Okay, betul, correct. Another thing that we need to take note of is they said neglect any energy transfer to or from the surrounding, which means that the system is in the substances are in an isolated system. All the energy released will be absorbed by the other guy. Tak tahulah guy mana kan, tapi in this case, the guy is the water because water, the temperature is lower, which means that water tu, which means that the water will be absorbing the heat from the iron. So tu ikut common sense. Ni baru common sense dulu So kita letak metal panas dalam air, what happens to the water? It becomes hotter. So it means that the water will absorb the heat energy from the iron and the iron will release the heat energy. So iron akan jadi cooler. So let's do that. So Umar is correct. And another thing we need to take note of is if it's in an isolated system or not. So yes, it is in an isolated system. All right, so let's do the equation. Okay. So in my Q iron is MC delta T. Okay, so let's just calculate that first. We don't know what the final temperature is for the iron. Okay, jap. Okay, I know this is new to you, so sabar jap I need to gather my thoughts juga. So M mass of iron, okay, C iron, delta T iron. So delta T iron, what is the delta T of iron? What is our T naught or T initial?
500.
500. What is our T final? Do we have a T final?
Not yet.
No,
Not
yeah.
yet. So we are trying to find the T final, right? Okay, so T final of iron minus the T initial of iron, which is 500. Okay, so let me, okay, tak apa, kita buat dulu. orange. Okay, so now I want to make this equal to Q water. So water will be absorbing this heat, which means that it will increase in temperature. We don't know if it's going to turn into steam or not, possibly, but kita akan assume dia tak tukar lagi lah. So let's go with MC mass water, C water, T final minus initial temperature of water, which is minus 22, which is 22. So T final minus 22. Is our T final for iron the same as our T final for the water?
No, same.
Same sebab?
It
Because they
reached
reach an
minus
equilibrium.
Yeah, so here they give a hint. Reaching equilibrium, which means that equilibrium happens when there is no heat transfer, and that can only happen if they have the same temperature. So objects in thermal equilibrium means that they have the same temperature. So T final, water and iron has to be the same. Have to be the same. Have. Dua-dua benda. Okay, so let's do this. Mass of iron is 0.4. C iron is 448. This is in joules per kilogram per Celsius. This guy is already in kilogram, so that's great. T final, we don't know. Let's label this as TF minus 500 equals to mass of water, 20 kilogram. Sea water is 4186. This is also joules per kilogram per Celsius, sama. So tak payah risau kat situ. Memang akan sama lah. Unless dia macam nak bagi korang make the question complicated and change the units. But otherwise, it will always be joules per kilogram per Celsius. Selalunya dia tak tukar lah. Okay, jangan panik. Okay, so T final minus 22. Okay. What is my next step? I know you guys don't like math, but physics ada math. Apart from theory. Oh no, saya terpadam ni. Kejap. I don't want to padam. Sekejap let me do some housekeeping. Group, make it smaller. Okay, you can stay here. Okay, stay here. Okay, so now I want to move this upwards. All right, so let's do this equation. It's a simple equation really. So, padahal saya pun tak suka math. So 0.4 times 448 times TF. So that will give me 179.2 TF minus 0.4 times 448 times minus 500. So that will give me 89600. So 20 times 4186 times TF 83720. Oh, okay. Here I made a mistake. Ada orang tahu tak apa yang saya silap kat sini?
Negatif.
Negatif dengan negatif. Ke mana
Saya
negatif?
tak, I mean ada negatif dekat Q iron.
Ada negatif dekat Q iron.
Negatif Q iron sama dengan Q water.
Negatif Q iron sama dengan Q water. So this is what Umar is saying. Okay, let's see. Sebenarnya saya silap dekat sini ya. I'm not sure about this one, tapi saya rasa macam betul. But let's see. I made a mistake here. Okay, we are releasing energy, which means that my 500 will be bigger than my TF. Betul tak?
Betul.
Okay. So this guy will be negative Q. Betul apa yang Umar cakap tu. But I don't know for sure yet. If our calculation will show that. So let's do that and tengok jawapan dia betul ke tak. Okay. Are you guys following me? Faham tak apa yang saya cakap ni? 20 times, ke tak faham lagi? Tak faham tak apa, nanti kita recap balik. 20 times 4186 times TF 872. Lama tukar kali pula. So that is 83720 times minus 22. That is minus 1841840. Okay. Okay. So that should give me 83720 TF minus 179.2. Yeah. So if I put this over here, 891841 1841840 minus 9,600. So this guy will become 1752240. I just put this guy over here. Okay. And then TF kita nak kumpulkan ke sini. 83720 minus 179.2. So I'm bringing this guy to the other side, to the dark side. So it becomes 83540 40.8 TF. Okay, so takutnya what's the answer? 1752240 divided by, saya tak suka lah banyak-banyak nombor ni. 83540.8. I prefer to deal in symbols. So TF is 20.97. That's wrong. Sebab kita tahu kita punya temperature of water will increase.
They need to make the Q ion into negative. So it will change the
Yes,
sign.
We need to make it negative.
Either we make negative or we change 500 minus TF.
500 minus
Both
TF.
can.
Okay, that sounds like reasonable sebab Q ion will need to release the heat energy. Q water will absorb, so it will become positive. Okay, let's try that. So if we put the minus sign here, this guy will flip. Okay, tak payahlah tengok flip tu. Just put the negative sign. Okay, so if you have the negative sign, this guy will be, terbalik je lah nombor dia. Negative plus. Okay, so will I get the right answer, Umar? I don't know. I don't want to look at
Yeah,
this.
you will get it. You will get it.
Yes.
Get it. 83720 plus 179.2. Okay. So that is 8389. Kenapa lambda? Okay. Negative and then this guy is positive. Okay, betul. So that is 839. Okay. 838.2 TF. So I brought this guy to the other side, becomes a positive. This guy, bring it over here, becomes positive. Hopefully that will be correct now. 89600 plus 1841840. So it's 1931440 divided by 83899.2. So we get, saya terlebih kosong lah kejap. Apa nak kira? Okay. Okay, sebab saya terlebih kosong somewhere. So 89600 plus 1841840. 1931440 divided by 83899.2. Yes, I got it. So 23. So tadi kat sini 1931440. Okay, so TF becomes 23 degrees Celsius. Okay. Okay, so let me think. This guy needs to be negative so that when I add it to the water, it becomes 0. Okay. Minus Q. Okay, let's see the solution. Okay, where is it? Okay, so they use the net Q equals to 0. Q iron plus Q water is equal to 0. And they, okay, so this is how they did it. So TF minus T minus 500, TF minus 22. They put it on the same side if they don't want to do the Q iron minus Q water. Okay? Okay, so Umar was right. So Q iron plus Q water equals to 0, which means that if I put Q iron on the other side, it becomes negative Q iron. Okay, so there's two approaches to do this. Either you use minus Q iron. Somebody is releasing the heat. So in this case, it's the iron. It's the iron and the other guy is the water, sorry.
Doktor yang cakap negatif Q iron tadi Fakri.
Oh, sorry, Fakri. Was it Fakri? Sorry. Thanks, Fakri. So minus Q iron equals to Q water. If you put this guy on the same side, plus Q water equals to 0. To me, you can use either way, it doesn't matter as long as you understand what you're doing. So we had an error just now because I forgot about the releasing. Okay, so that was my bad. Thank you for helping me out. So here we need to remember that the guy that is releasing should be negative, the guy that is absorbing is positive. If you want to use delta Q equals to 0, then this would be Q iron plus Q water. But in this case, you don't have to flip anything juga. T final minus the temperature. So T final always minus the initial temperature. Okay, that is correct. Tadi kan, previously I said we could flip here. No, I was wrong. Tak boleh sebenarnya. Sebenarnya it's just the negative sign. So delta always final minus initial. So the negative sign here, keep it. Okay. Okay, let me recap that for you guys yang if I confused you, we need to use either minus Q iron, which is the substance that is releasing the heat, becomes negative. This is the heat loss this is the heat loss. This is the heat gain. So heat gain maksudnya positive Q, heat loss maksudnya negative Q. So minus Q iron equals to Q water. Or if you like to use this equation, net Q equals to 0 equals to Q iron plus Q water. Pun boleh. And your delta T will always be T final minus whatever temperature of your substance. So tak payah flip. Don't flip it. It will confuse you. Dalam jalan kerja on the internet, they usually flip it. So that is where the confusion comes from. They flip T naught minus T final. They go for higher temperature minus a lower temperature. Don't do that. Go for T final minus T initial. Kejap. I think it's my son. Okay, is everyone okay with this? Did I manage to confuse you guys? I hope not. Okay tak? Okay.
Okay.
I hope it helped that we did this together and discovered the confusion together. Okay, so hopefully next time kita dah tak confused dah lepas ni. Alright. Last exercise. Is it the last one? We have 14.7. Hello. Okay. So this is the last one. Okay, so this is the last one for our class. Yay! So chapter 14 habis dah. Okay, so duplicate this again. Sekejap. Alright, so jawapan kat sini 11.1. Okay. So exercise 14.7, our last one and our final lesson for chapter 14. 100-gram ice cube. So our mass. So we have ice and we have water. So let's write that down. Ice M is 0.1 kilogram at 0 degrees. So T initial is 0 degrees Celsius. Added 650 gram of water is added 100-gram ice cube at 0 degrees Celsius is added to 650 gram of water. So mass is 0.65 kilogram. T naught is 25 degrees Celsius in a thermos flask. Thermos kita tahu it isolates the inside from the environment. Macam susah nak lose heat ataupun susah nak absorb heat. So this guy, we can assume this is an isolated system, or we can say that it's a calorimetry, just like before. What is the final temperature of the mixture? Okay, so now we are more prepared. But now it has become more complicated. We have latent heat of fusion here, and we have seawater. Just now we just talked about Q iron and Q water. So it was straightforward. Now kita ada LF, but now we are more prepared. Kita dah tahu macam mana nak guna equation T, delta T tu, and we know which is minus Q, which is positive Q. So let's do that first. So here our ice cube at 0 degrees Celsius is added to 650. Okay. So how should we do this? So ice, it will absorb heat. So it is already at 0. So dia terus akan jadi LF, right? So dia terus akan jadi ml. So this is my ice. So dia akan jadi ml, and then dia akan increase in temperature by mc delta T. Whereas the water, this is for ice, whereas the water, there's no ml going on, and it increases in temperature. So this guy only has mc delta T. This is equal to 0. This is net Q. Kita pakai equation ni pula. Net Q equals to Q ice plus Q water equals to 0. Q ice is started with 0 degrees Celsius. Of course, if I absorb heat, if I put in ice into my water, the ice cube will melt. So kalau dia nak melt, it has to go through ml, latent heat. It also has to go through mc delta T to increase in temperature to the final temperature. Okay, so this is ml plus mc delta T, whereas Q water, there's no latent heat involved because dia tak jadi steam, maybe it decreases in temperature because of the ice, so the water becomes cooler. Okay, we don't know. So let's solve that. Okay, so ml, the mass of ice is 0.1. Latent heat of fusion, I want to convert my ice to water. This is 3.33 times 10 to the 5. And that is my change in phase already. So ice 0.1. C, what C should I use here? What C should I use here?
Seawater.
It's not sea ice?
No.
No,
No.
Because it already changed.
because it already changed. Correct. So seawater 4186. And our T final is the temperature that they reach equilibrium together. We know this. T initial is 0. Tak cukup tempat. And then plus mc, mass of water 0.65. Sekejap let me find some space. Are you guys still with me? Ke dah tertidur-tidur dah tu? Are you guys
Yes,
still?
Doctor.
Ada Doctor.
Okay, that's good. Okay, sikit lagi last question. Okay, 0.65. 0.65. T final is the temperature that reach equilibrium. We are assuming the water becomes cooler because of the ice, but we don't know. And then T initial is 25. So this will give me this whole thing. Okay, just by looking at this, just by common sense, we know that the T final will be smaller than the initial. So we can say that, okay, I am expecting this guy to be a minus Q because it will be releasing heat. Where does the heat go? The heat goes to the ice. This guy will be a positive Q. This is assumption. Okay, so let's solve it. Alah, malasnya. Can we just look at the solution? Yep.
Untuk water tu,
Yes?
untuk kat water tu.
Yang untuk water.
Yang
Oh, C.
MCT.
Okay, I forgot it. Thank you. T. Thank you, Mariam Aisyah. Okay, tak boleh padam je lah. Pemalas betul kan? Sekejap Nak korang je malas. Saya pun malas juga. Cik. I'm not proud of it. I like to skip things too. So that was a problem when I was doing my degree. C. C is 4186. Okay, so 4186. Okay, so now hopefully we can solve it. Let's just look at the solution. If we got it right or not. Last one. Okay, so dia buat Q ice plus Q water equals to 0. And mass of ice. This is the LF for ice, 0.1. And then they use sea water. This guy is sea water. Sea water. LF. And T final minus 0, which is our T initial for ice. And then 0.65 is the mass of water. This guy is sea water. And T final minus 25. Okay, it looks like we got the working step correct now. Thank God. So just multiply lah. This guy gets you a number. This guy will get you something with a TF. This will become a 0. Something that is multiplied with a 0 gets you 0. So that's good. This guy gets you TF, and then you get a negative value over here. So you only have one part of the equation that becomes negative. So that is where you're losing heat. Okay. So TF is blah, blah, blah. You get the answer. Okay. So, asalkan kita faham macam mana nak buat jalan kerja, that's good enough. And hopefully you can do your web assign correctly now. Okay. So any other questions for me before we end class? Okay, is everyone okay with calorimetry now?
InsyaAllah, okay.
Yeah, insyaAllah. Alright, so for your best, I want to inform you that your quiz, there is a message circulating, I don't know if you got it, that says that quiz is on Friday. Did you get it?
This Friday.
Dapat tak?
Yang tu tak dapat, tapi kami dapat.
Yang dapat week 5 tak sedap.
Dapat tu nak cerita tukar ke week 5.
Oh, yang dapat yang hari Jumaat itu tak tahu Tak dapat
Tak tahu. Tak.
Oh, okay. So okay, so kelas lain dia tengah panik. Diorang ingat macam ada quiz on this Friday. Kesian. Anyway, it's not true If you guys get the message, it's not true. I don't know siapa yang pandai forward, but it has been forwarded many times and ramai students dah gelabah. So it's not true. Our quiz will either be on weeks 5 or week 6. It's not confirmed yet. I will let you know as soon as I know the official date, I will let you know. But it's either going to be on a Friday evening on week 5 or on week 6. It will be around 8:30 p.m. to 9:30 p.m. It's only 1 hour. It's MCQ, 20 questions. So it's only on chapter 13 and chapter 14. So kita dah habis. You guys can start studying for it. We are already in week 3. You guys have 2 weeks to go. You can ask me questions. You can do this personal WhatsApp, or you can ask me at the group. You know the drill. Okay, so all the best. Study hard. Your quiz is 5%. It's not much. You know, I think you think it's not much, but it will help you get an A. Or if you want to increase your grade from C to B, it will help you. So do your best. Jangan sia-siakan because 13 and 14 is the easiest compared to the rest of the other chapters. 13 and 14 paling senang sebenarnya. Walaupun nampak leceh. Okay? So all the best. Okay, tu je. Okay, have a great day and don't forget your lunch. Take care. If you are sick, let me know. If you can't attend my class, let me know. Alright, so bye-bye.
Thank you, Doctor.
Thank you.
Thank you, Doctor.
Thank you, Doctor.
Bye-bye.
Doktor.